This is my battery cutout switch. This is configured for a Makita battery customer request. I have an input voltage of 18 volt. This is the operating voltage of a Makita battery. We have a voltage divider in here. I have to change it from a car battery. A car battery has 14 volt charging voltage, but runs on 12.7 volt and turns off at about 11.8 to 12 volt. The Makita has a charging voltage of 21 volt. But I'll show you something. 18 volt it got now input, but because of the diode and then the fuse, we actually get only 17.4 volts, so 0.6 volt less we're actually getting in. That has to be considered in the software. And out comes at the voltage divider 4.29. These are the figures we put into the software. I'll show you something. It can cope with 21 volt. So not more than 5 goes into the chip. So we don't leave it too long because the resistor is not high enough, gets hot. And that we do not damage a battery. This switch turns off the power to the battery, that the battery doesn't get damaged. Like I say, it's not relays, it's MOSFETs that can handle higher voltages. And we fine tune it now and show you what it does, because this is an indicator before it goes really low. It starts blinking and telling you to charge the battery. The battery is getting low, because under 16 volt you damage the battery. So we go lower now, check what it does. 16.6, 16.5, this is 4, 3. The indicator still goes. The 16.2, the whole thing shuts down. So the battery input and here the output, whatever you connect, lights, a fridge or something, disconnects from the battery in order not to damage the battery.